All right, honored to be here. OSDI has actually always been my favorite concert. No offense to ATC, which I've also submitted to and had papers out and attended. But OSDI has kind of been a special place for me historically. So, at first glance, I'm going to tell you that there's security problems in open source, and I would not be surprised. We got one of these mics is on, maybe this one. Well, we'll find out. This is not news in some sense, and I'm going to try to actually convince you that it is actually a bit of news, and that a few things have changed, and that it actually is something we need to revisit way more seriously than we have. So, yes, the first obvious thing is way more use of open source. I'll get to that in a minute. But really, what's changed is it's permeated society, and it's in lots of things that we depend on every day, and that includes most nations. Most nations are actively encouraging the use of open source, in part because it's free, but also in part because it's competitor-led. Sorry, competitor-free.
We're going to fix this.
All right. I'll move it a little more. Sure. All right. So, because nations count on it, they're starting to get nervous about it, and their answer to nervousness is regulation. That's the real source of the Biden executive order, which is not specific to open source, but it absolutely explicitly covers open source, and we've had many discussions with the government about that. And maybe another thing that's going on here is we've changed the way we distribute open source from essentially something that came with your Linux distribution and was relatively vetted to something that comes from a range of package managers and is not vetted at all, right? So the way you receive open source actually is a less trustworthy path now than it used to be. And finally, maybe we've even fixed some other security problems that have made these kinds of attacks more like the weakest link. That's an unfounded statement. I have no data for that, but it does seem like there's been a shift in attacks, especially in the last 2 years. So open source successful, and I spent a lot of time on this, but big picture, it's growing like gangbusters. Right? 2.2 trillion downloads of open source packages last year, 6 million new versions of things, 800,000 new projects, right? That's 20% growth year over year. And even proprietary applications, 90% of them based on Forrester did some interviews of developers in companies, 90% of their applications have open source inside. So this is not just, open source is going to have different problems than proprietary stuff. In fact, I actually would argue that we need to fix the proprietary applications also, but we can't see them the same way. So if we can figure out how to fix open source, we'll, as a consequence, also learn how to fix closed source, right? So this is our playing field to figure these things out. Critical to society. Well, what do I mean when I say it's critical? Well, I mean that it's in the basic things you use, certainly Linux and OpenSSL and LLVM and Kubernetes. I got into this because of Kubernetes. We'll come back to that point in a little bit. But these are widely used open source projects that financial services depend on, lots of things depend on. All clouds depend on open source in a huge way. All connected devices, right? Your smart TV, is it spying on you? How do you know? I'll just say I don't connect my smart TV to the internet. I recommend against it. Your Wi-Fi hotspot, those are a disaster waiting to happen. If that's running an old version of Linux with probably the admin root password. Electrical grids, there's already been attacks in Ukraine, US, and India. The attacks in US we know about because 4 Russians were indicted for attacking the US electrical grid. There were no consequences, but the attack did happen. Water supplies, someone changed the chemical level of a water supply in Florida over the internet. Oil pipelines you've heard about, ransomware. Telco has a huge amount of open source in it, right? Obviously TCP, but much deeper than that. OpenFlow, lots and lots of use of open source, which is great. It's made telecommunications one of the more enlightened sectors. And of course, government itself, agencies are using open source for all kinds of things. So, you should care that these things actually work, right? And of course, there's lots of attacks. They're all pretty significant. I don't want to cover these other than to say that each of these is like a big reaction for governments and for companies. And this arrival rate is too high, and this is not even counting them all, right? And so when you get this kind of arrival rate of big problems, you get this top-down pressure to fix it. And so again, that's partially the executive order, but also it's like changes in FedRAMP regulations, and NIST has many new documents on what you need to do for procurement for US government. And they're really driving about, well, we can't make developers do the right thing, but we can control what we buy and say, when we buy something, we'll make sure it has all these security properties, which by the way, are not gonna be easy to implement, and they're not well specified. But EU and UK have also had discussions about what they want to get out of their systems, right? What enforcements they're gonna put, what penalties they're gonna put in for software. All these apply to open source, whether or not the regulators think about open source at all, right? So this might even be an existential threat to open source accidentally, right? Which I'm working to prevent, but I think it's on the table. And finally, if you're a citizen of these countries, you actually want them to care, right? You should want them to care about your electrical grid and your water supply, and not to mention airline scheduling and all kinds of things that depend on software every day. So this pressure's coming. It's here now a little bit, but it's gonna keep coming. And it's not just governments, of course, it's brands too. Brands have been severely hurt by their software vulnerabilities, the most famous of which was absolutely open source with Equifax using an old version of Java struts. Basically, they're kind of almost gone. They were, had to be rescued, largely wiped out of their sector. They still exist, but it's not the same company. So they should also care. So it's not an easy problem to fix. In fact, I would say in my career, it's the hardest problem I've tried to fix. And that's saying a lot. I tried to fix, healthcare in India. This is harder. But let's talk about some fundamentals to figure out how we want to make some progress here. So this is a famous quote from Eric Raymond when he kind of wrote one of the original open source papers, Cathedral in the Bazaar. Given enough eyeballs, all bugs are shallow. And the idea is that the transparency of open source inherently gives it a fast rate of bug fixing. And implicit in that, and often meant by that, is it's more secure, right? And I think that's right on average. There are more eyeballs, and the transparency does help, but it only helps on average. It doesn't necessarily help on any given package. And one of my things I want to convince you of is the eyeballs are not spread very well, and that's a tool we have to fix this situation. So let's start with the basics. Do you trust a package? And my claim is sometimes packages have 0 eyes on them, 0 eyes that are effective. And the first stat for that is we looked at all the open source packages. We literally crawl them all. And 30% of packages have a single maintainer. So that has 2 problems. One is individuals are highly random. As a distribution, there's going to be a tail there that is not great. But also, there's no checks and balances for these packages. If someone was to make a bad change, no one's there to catch it because no one else is looking. Right? So when I say 0 eyes, it's not literally 0. It's that we have the one person who's responsible, and we're trusting them completely, whether we know it or not. I'm going to give a bunch of bad examples here of things that happen with single maintainers. The first one, event stream, is basically, it's a kind of, a lot of these, by the way, are actually all of these are, in this case, are NPM packages. I'm not picking on NPM, but they are entertaining. And they're used in the front end, so they tend to lead to things that are more spectacular. This is a small package that doesn't do much, but basically the attacker just asked the single maintainer if he could take it over because the single maintainer wasn't doing much with it. And the maintainer did give it to him. He said, look, this is a package I don't use anymore. I don't really care about it. If this new guy wants to maintain it, that's great, right? Reasonable response. The problem is the attacker, of course, who's anonymous, then put malware in it. It still has 8 million distributions every week, so widely used, automatically deployed lots of places, led to all kinds of credit card theft. Actually, this one is Bitcoin mining. That's another thing that changed. Bitcoin mining makes it profitable to do some of these attacks in a way that wasn't true before. So you can get Bitcoin mining on 8 million JavaScript front ends every week. That's a pretty profitable thing. Another maintainer lost his credentials, right, because he wasn't using two-factor authentication. So you see a lot of authentication pushes in open source now. Another guy, the left-pad guy, basically was in a trademark dispute, got sick and tired of open source in general, and just pulled his package, except that it's widely used and lots of people missed it. And so that broke the internet, so to speak. And again, this is not, it's absolutely the person's right to remove their package, right? It's very clear that they're not obligated to keep it there or to maintain it even, right? So that's on us for assuming that it needs to keep working. The other thing that's bad about this is it was an 11-line package, right? It does left padding with spaces, right? So we shouldn't depend on 11-line packages, just as a general rule from random people. That's a bad precedent. And most recently, colors.js was this package where the maintainer who was protesting the invasion of Ukraine made a version that was mostly innocuous, supporting Ukraine with, I believe, a peace logo. If you ran it in Russia, it actually deleted the files on your system. Right. So it was also an attack, and that was a bit disputed, but there's good sources now that say that actually happened. The point is, an individual maintainer has this power, and it's an unchecked power essentially today. It's really because we're assuming there's enough eyes to prevent these kinds of things, and on average that's right, but only on average. But that's just one package. When you get to lots and lots of packages, you have a totally different problem. Right, 90% of your vulnerabilities are not in the package that you're thinking about, they're in the dependencies of the packages. And dependencies, especially when you're using 11-line packages, are very long and deep, right? There's hundreds and hundreds of packages. Like I got in this because Kubernetes had at the time like 1,200 dependencies, and they weren't all trustworthy. And this was about 2018 when I started thinking about this problem. And when you have that many dependencies, you can't really look at them all. And even if you could look at them all and say, oh, okay, I'm going to do an audit and check them, are you going to do the same audit in next month, next quarter? Because they're all changing all the time, right? Kubernetes has like 45 commits a day, every day, right? It's changing all the time. So how are you going to keep up? Log4j is another example of this where is used in 8% of all Java packages, which means it has very wide reach, right? It's deep in the stack, though, in all these things, right? It's not at the top. And so it's very hard to even know all the places you use Log4j. And many corporations had a kind of emergency situation, Google included, where let's go find all the uses of Log4j, because we don't have an inventory, we don't have an index, we have grep. That's our tool of choice for finding Log4j. Not a great tool for that use case. Again, because that only helps find direct dependencies. So, and even if you could find it, it's because it's deep in the stack, you have to literally fix everything from your application through all the packages down to the thing that's actually got the vulnerability, because all of them need to have at least a version bump. And if any of those things are on older versions, you have to basically change the call site to bring up, to be able to use the new version, then you get the security patch. So it's very common, Google has this problem too, to get stuck on an old version because you can't just do a trivial upgrade. You actually have to rewrite the calls because the semantics have slightly changed. And we have certain things inside, like the Perl registration library. We've been trying to get rid of that for years, but all the uses of it are slightly different. You have to look at each one to figure out how to rewrite it and make sure it's safe, so you just get stuck. Right? So it's really actually quite hard to deal with these deep in the stack dependencies. We made a tool, Google Open Source Insights, it's at the site deps.dev. It's pretty useful for this. It's free. Basically, you put in your package, it will tell you transitively all the things it uses and all of the vulnerabilities in those things. Right? That's a super useful tool. If you do any work in open source, please try it. You'll be scared by what you find, but at least you'll find it. Right? Awareness is the first step. The picture on the right is the dependency graph for Kubernetes, although it's only part of it because it wouldn't fit on the slide, realistically. Right? So this is the picture that roughly scared me. I'm like, oh, we got a problem. I spent a lot of my last 10 years on Kubernetes, if you don't know that. So It's something I care deeply about. I'm happy with how it's turned out, but I don't want it to crash because it's got security problems, right? And since then, we've reduced the number of dependencies. We still have plenty of work to do. So it is possible to make progress, but this is a great tool to actually understand your dependencies. Now I'm going to shift gears a little bit and say, well, what happened when this log4j incident happened? And this is a legal, I'll explain this more on the next page. But basically, this guy who uses just normal provider of open source got this legal letter. And basically, the essence of it is, we use your thing that uses log4j, so we need you to fix it in 24 hours. And you need to tell us if you had any incidents and what was affected. Also, did you lose any personal data? And what is your remediation plan with steps and dates? Right? You can imagine that legalese letter. And this is all well documented online. But this is not how open source works. Right? You don't get to send legal letters to your open source suppliers. In fact, it's very clear that open source is free but as is. It literally says that on every file. That's what the license says. That's one of the things the license says, right? No liability, but you use it as is at your own risk. And that's the right policy, given that it's to a large extent by resource-constrained developers, often volunteers, limited investment for ongoing maintenance, or really for anything that's mundane. It's hard to get maintainers to do the stuff that's not the fun stuff, and I don't blame them, right? I did a lot of open source work. I did the fun stuff, right? No one wants to go do the less unfun stuff, especially if it's a volunteer job. And so there's it doesn't mean all maintainers don't do that. Some do a great job, but they have to understand it, and of course there's going to be a wide variation of what people actually do on this, what I call the mundane work. So wrapping up this part, I think things can be secure, and many eyes do make all bugs shallow. We just have to make sure we're getting eyes on the right things. And so I'm going to shift gears and talk about one idea that I've been pushing to fix this, called curation. It's not a new idea, although it's an extension of, as you'll see, of things that we've been doing. And I mentioned that we don't really get open source the same way as we used to. And what I really mean by that is this slide, which is there's really two roles for a supplier of open source that we need to think about. One is the distribution. How do I get open source from the suppliers? And the other is accountability. Who's going to fix it when it breaks? Right? And package managers, which is the main way people get packages now, they do a fantastic job in distribution. That's what they do. They are fantastic for distribution. That's why they're popular. They have all the packages, right, including all the ones you shouldn't be using. So they're great for that. Again, they're delivering as-is packages. They make no promises either. Classically, we had things like distros, like a Red Hat or Debian, where they were doing a mix. They would do distribution, but they were also doing some accountability. So for example, Debian would make sure that all their packages work together. That actually requires work and effort. Red Hat famously gives you a support license where they'll fix the security bugs in the packages they give you. And they'll do it even for old versions, right? So that really is the essence of curation. It's a supported version of open source. But Red Hat and Debian do it for a kind of a narrow subset of low-level packages, right? They're not helping with NPM packages or your front-end JavaScript stuff, right? It's not in scope. These roles, distribution and accountability, are real roles, and we need to figure out who's going to play each role. And it's actually perfectly fine for me if package managers say, we only do distribution, but let's call it out and name it. They only do distribution, right? If they want to take on accountability, that would be fantastic. If a maintainer wants to do it, that's fantastic, right? If no one does it, that's not great, but at least we should be talking about it that way. There's no accountability for this package. Maybe we can fix that. So you can think of curation as being this missing layer where we have this kind of amorphous top-down requirements, whether they're from an executive order or from legal letters or corporate policy, right, versus our kind of bottom-up open source as-is software, right, those are fundamentally incompatible, right? They just are, right? High expectations, no promises, right? Those don't work well together. So curation, in some sense, has to be the thing that bridges that gap. You can think of it as curated open source with support. But it's more complicated than that, because first it costs money to do this. The good news is I think there's money in the system, because the same people that have top-down pressure actually all have budgets, right? So we need to tie, you want to get something that's supported, you have to pay for that. If we can get that money down to the maintainers, that would be good too. We'll talk about that a little bit. But let's not shy away from the fact that this isn't going to be free and shouldn't be free. This is things like OpEx for testing. Is it fair to ask maintainers to pay a cloud to run their test cases using their own money? Clearly not, right? I think most clouds would be actually happy to help maintainers run their test cases if there was an easy mechanism to do that, right? So that's one thing that costs money, independent of headcount. The OpEx is significant as well. So you can think of curation as kind of open source with support. And if you're doing curation, it means you're fixing vulnerabilities. It means you're updating old vulnerable dependencies. So if log4j is something your thing uses, then you need to fix the path of dependencies up to your thing. You need to work on automation. You need to work on testing in general. Most of the time when we have a fix for open source, we don't really know if it works all that well, because there aren't enough test cases to say, yes, this will work and not break stuff. But again, writing test cases goes in the mundane work category, and it tends to be underfunded. So test cases is another thing that curators should do. But another way to think about this is about putting eyeballs on the things we care about. So we're starting to look at what is critical to financial services, and to electrical grids, and to agencies. And we can actually say, oh, these things look like they're critical. Log4j is critical. We didn't know that before. Now we know it's critical. We can put eyes on it through curation, right? Curation is a way to take money and turn it into eyes on the things that we care about. And of course, you'd like this to be like any other support. Well, maybe there's some service level agreement, maybe there's some liability protection, probably could get reduced cyber insurance rates, which actually is a real thing, and that would make people more likely to use curated software if they got discounts on their cybersecurity insurance. But of course, it can't just be a simple layer, and so I'll just draw some ways this could work. It could be that you have your top-down expectations. And by the way, there aren't one set of those. There's many sets of those. There certainly is a different set for each country and maybe even each state. But also, corporations or sectors are going to have different expectations. And so you can, say, well, one way to do curator is I'm going to have a maintainer who also does support, and you just pay the maintainer directly, and that would be great. That doesn't really happen today. It does for like OpenSSL because of Heartbleed. There's two Steves work on Heartbleed work on OpenSSL part-time. Post Heartbleed, the industry decided we should really pay those people. Right, that's a critical thing. They should be able to work on it full-time versus part-time. You can get monetized open source, something like Databricks, where you can use Spark, the open source version, but if you get a company version that does in fact come essentially curated, right? I've not talked to Databricks about this. I'm sure there's Databricks folks in the audience, but I would assume, like with GKE, which is the Google version of Kubernetes, if you use GKE, we're going to fix whatever we know about in Kubernetes that makes it have a support system for you. So when there's companies monetizing open source, that can be the mechanism for curation. But also, just philosophically, there's going to be curators of curators. It might be that there's a financial services curator, and they only work on things that are specific to that industry, but they then want to work with Red Hats and others to kind of get their sub-dependencies curated. Right? So curators of curators is a very logical thing to do in this model, and I think we'll see that as well. Google's trying to experiment in this now. We've announced, but have not really launched yet, a product called Assured OSS, and you should think of it as just a trial experiment in curation. And what it is we're already using a bunch of packages internally where we do do the security patches, and we do track the dependencies, because we use them and we need to. Since we're doing all the hard work, we might as well make those versions available to others. So right now, it's just going to be Java and Python. It might expand later. It'll only start with like 100 packages or something, but it's pretty plausible you could add packages every quarter and get up to a pretty good number eventually. So what do you get with a curated package? Well, it means that we're going to do all the things we already do internally, which is scan the packages, run static analyzers, run fuzz testing. Oh, and fuzz testing, by the way, is also very expensive, right? So it's another place where you can't do fuzz testing without curation, essentially. We give you metadata about what tests we ran and why we believe it's viable. We'll build it with metadata for building, which I'll get to later. That's what Salsa is. We'll sign it so you know you have our version, and then we'll put it in various places where you can easily access it. And this is not to say that we're forking these things. The purpose here is not to fork them, but you can think of it in some sense as we're going to make a temporary fork to fix the problem, while in parallel, we try to upstream the solution, right? Which is what we do now, but that can take a month or two, or sometimes longer if the maintainers don't agree on how you solved it, right? So this is a way to get a secure version that someone stands behind, get it quickly, and then, but not fork it, right? So far, we haven't had to fork anything, but we're also picking packages that are kind of relatively stable, too. So that's the experiment. We'll see how it goes. What should you want out of a curator if you're a maintainer? And I say it this way because, again, maintainers are still operating in the free as is mindset, as they should, so they don't even have to work with curators at all, right? And that would be a shame. So we want to treat this as a two-way street and say, well, maintainers should be getting something out of this deal. And part of it is, good curators should actually be making contributions, not requests, not legal letters, but actual, here's fixes, here's test cases, here's good pull requests. I think it's pretty plausible, and this is a place where I think community could help to do a better job of proof of automated testing. So for example, if I have an easy token that shows that, yes, here's some changes, and I can prove that my changes pass all your test cases, right? That would be very useful for a reviewer trying to decide, is this change worth accepting? Is it risky or not, right? So there's lots of things where maintainers and curators could work well together with a little bit more infrastructure help. It'd be nice to share the wealth. I do think there's a path down going forward where either directly or indirectly through foundations, I'll get to the foundation in a minute, curators, they're getting paid and are using dependencies, they can share some of that wealth to make sure the things that they care about are fixed. Because again, the trade-off is that if they don't get it fixed by someone else, they have to fix it themselves, right? And so there is some value in there in paying a third party to fix stuff, even if it's a maintainer, or maybe especially if it's a maintainer. And then once you get to a crisis like Log4j, you should be, curators should be driving a lot of that incident response and helping with a lot of the difficulties of doing that. It's actually quite hard on a small open source package team to deal with any kind of public security issue, right? The incoming emails, incoming press requests, right? Hate mail, all kinds of stuff, right? So there's lots of room for help on that front as well. And then again, there's not any tooling for this, generally speaking. There's a little bit, but in general, I can't take a package off the internet and easily build and run its test cases, right? You have to know that specific community's process and their Jenkins files or whatever to do that, right? And it's actually a shame, because I think, again, if it's easy to run test cases, more people would run them at their own expense. OSV is a vulnerability database. It's an alternative to CVEs. The problem with CVEs is they're very English-oriented, right? They talk about a binary and they list in English problems that they found. And that means it is not automatable. And that works fine if you want to have 1,000 CVEs a year. It does not work fine if you want to deal with the tens of thousands of vulnerabilities we actually have, right? We have to find a path to automation. And I won't talk about this much, but even things like how do version numbers work, resolution is when I have multiple demands on a package, which version actually gets picked. In general, you can't know that today, which means you don't really know ahead of time which version you're going to get of something, In fact, in general, the only way to know which version you're going to use is to install it. And that's a problem for lots of reasons. One reason the problem is when you install it, you run it as you, and it has init scripts that are untrusted that also run as you, that have been attacked just in the initialization scripts. And so, there's lots of things to fix here. But then things get a little worse. So all of what I've talked about so far is just kind of the fundamentals of open source and how the as-is model doesn't work well with top-down pressure and how to address that. Supply chain attacks, as I hope will convince you, are kind of like a big lever that make this problem a whole lot worse than it would otherwise be. And the reason for that is supply chain attacks really have two phases, and the first phase is kind of a normal attack, like you could do with any of these single maintainer things or any weird dependency issues. But you're attacking, that first attack is on the supply chain, and then the second phase of the attack is all the users of that tooling system, right? They get attacked, and it's that amplification, which can be like a factor of 20,000, a factor of 100,000, that makes this attack so much worse, right? So SolarWinds is the famous one here. That's the proprietary closed source system, although it has a lot of open source inside, as I said before. And so, you attack that. That was literally attacked in the build process of SolarWinds Orion thing. That gets distributed. Now the malware is inside something that comes from SolarWinds, runs deep in the network of their customers, does lots of bad stuff, right? And that was a pretty scary, that's really the event that most led to the cybersecurity executive order, because it was clear it was affecting 20,000 companies. We don't even know the full number. I'm going to talk about Codecov, which is the same kind of attack, but on open source. And because it's on open source, we know a lot more about it, and it's more representative for the kinds of things I'm talking about here today. This kind of attack up 650% last year over the year before. So this is now in the arsenal of attackers in a way that was not true 2 years ago, right? So this is one reason I think there's a weakest link here, and somehow it's shifted in the last 2 years. So the Codecov attack, this comes from a company called Mercari, which is a Japanese retailer. They're very successful. They do hundreds of millions in revenue. So this attack essentially is on Codecov. So Codecov is a tool that does code coverage, not surprising, given the name. And the way it works is you have your kind of code typically in your GitHub repo. You might be using some GitHub actions, which are kind of event triggers. And so when you make a change, the event trigger says, oh, go run the code coverage test. And Codecov will run a bunch of tests. It collects that data for test coverage. It uploads it to the Codecov website, and then you get a nice dashboard with your code coverage. Useful service. Lots of people used it. Google used it a little bit. The way this attack worked is the attacker essentially discovered that they could get the credentials for Codecov and change the uploading script. So again, I told you it uploads test coverage to Codecov. That's a bash script. That's a good thing to attack, because then you can upload other stuff to other places, which is what's going to happen. How did they get the credentials for Codecov? Not uncommon. People leave their credentials in Docker images. Then they store those Docker images in public places like GitHub. And so if you scan Docker images for credentials, looking for the right regular expression, you'll discover lots of credentials. Now, the good news is Google and GitHub have both figured this out, and now we scan all the uploads for credentials to try to tell you to get rid of your credentials before an attacker finds them, right? So it's been defended a little bit, but bottom line is get the credentials out of the Docker image, upload a modified version of the bash script. And now what that means is because it's signed by Codecov's credentials, users of this new bash uploader reasonably believe they are using the one from Codecov and that it's trustworthy. It says it's from Codecov. It's signed by Codecov, right? But because it's not the real version, if you had a way to check the hash of it, you would know the hash doesn't match. There's other projects, something called like SigStore, where we actually are talking about, let's make essentially a ledger. It's not a blockchain kind of ledger, but yes, an immutable ledger where we store hashes of things. And so you could say, oh, what's the hash of Codecov supposed to be? Go check the ledger. It wouldn't match. Codecov could also check the hash itself and say, are the things we're distributing matching the hashes of what they should be? If they're not, then someone is uploading stuff with our name on it, right? That's catchable. It wasn't caught. Next step in this attack is you basically have this bad uploader. What does it do? Well, you run your test code coverage, and it runs the code uploader. And the first thing it does is nothing. And what I mean by that is it actually works perfectly fine. So in particular, like any good attack, it is continuing to do its official job of code coverage. So if you're using it, it still does code coverage correctly. All the data gets sent correctly to Codecov. It's producing the right dashboards. On all appearances, it is working perfectly fine, which is why it's hard to find. This is an 1,800-line file. One line was added. So this is a very small change, very hard to notice and review. This is the line. Basically, this says, copy the environment variables and do essentially a web upload to this website indicated by a redacted IP address. All right. That even looks plausible in this situation because you expect this is the batch uploader. This is a line that does uploading. Maybe Codecov wants your environment variables. Plausible. Why does the attacker want your environment variables, by the way? And the answer is because once you're not putting your credentials in your Docker image, you're putting your credentials in your environment variables instead. That's the best practice. And it is a better place than putting them in the Docker image, right? But it means if I can get a copy of all your environment variables, sometimes those will have credentials in them. So this is really a credential farming uploader. That's what this is doing. It's farming for credentials. And then the third phase of the attack, which is, or third step, second phase in my two phases, is really, I got credentials for Mercari and HashiCorp and 20,000 others. What can I do with those credentials? Well, I'll go look at their GitHub repo and look around. And maybe I'll get credentials to their production environment. That happened in some cases. Right? The credentials you get are kind of random. And by the way, this is not an attack on any particular company. This is not like spear phishing. This is kind of broad attack to collect credentials, see what credentials we get, and then just go through them and see what we can get. So what happened in this case was not so bad. Mercari lost its GitHub credentials. But that, as attacks go, that's not bad. So what could the attacker do? Well, they could get whatever's in GitHub. So they get source code. In this case, they also got logs, because the logs, it turns out, were stored there. So that was bad because those logs indirectly contain things like details about the merchants and their bank accounts. So there's a pretty big PII leak from this. But the production credentials of things that run in production from Mercari, those were not leaked because they weren't involved in the test coverage on GitHub. So that is in detail what a supply chain attack does and why it's kind of hard to deal with. There's the whole picture. And again, the picture came from Mercari. Production environment was fine, but yes, things were still lost. Last slide on this is just to point out, this was the timeline of it. I'm not going to go through it, but in that yellow circle is the fact that it was more than 2 months from the time of the change in the uploader until the time it was caught and fixed. Right? That's 2 months of stealing credentials. In fact, it's old enough that most groups don't even know what they ran in that period. Like, you know what jobs you ran 2 months ago and what credentials they were using. You probably don't. Maybe you have a log if you're really good at it, but certainly most don't have such a log. That's a long time, right? And kudos for the attacker for having a well-obscured attack, but that's a problem. So taking a step back for supply chain attacks in general, there's 4 different attacks in here, and I'm not going to cover them, but it's like they're injecting some bad code, they've compromised the build system, they've bypassed the CI/CD to make bad artifacts directly runnable, they compromised package manager signing. And so when you think about supply chain attacks, you should think about all of these lettered places on this chart have to be fixed. Right? Supply chain attack means you need a solution that addresses all of these attack points, and there is going to be no easy fix for this. Right? And this is often about invariance. How do I know what was used, what was built, how it was built, and how to get a reasonable signature out of it at the end. And that includes, by the way, what dependencies you're using and where they came from. So this is a hard problem, right? This is much harder than fixing a package or trusting a package. This is fixing all of the work that goes into it. So Google has solved this problem internally in the sense that Google got attacked by a nation state more than 10 years ago and started going in this direction of our internal supply chain, except the Google solution is very googly, and I don't mean that in a good way. It's you know, if you happen to have a giant mono repo, it might work for you, but I don't think anyone else does. There is a single trusted build system, which I do think is a model people should adopt, meaning that you're not allowed to build stuff on your laptop and put it to production. You have to build stuff in the trusted build system because it can enforce all the invariants I'm going to talk about in a minute. But it does other things it does too. For example, we know all of the authors and reviewers. We have strong identity for them, which I'm not advocating for in open source. That's a longer conversation. But it means that we know that code is reviewed by 2 independent people. You, in fact, cannot run code production that hasn't been reviewed by independent people. Right? That's a nice invariant to be able to say. I forgot this one, universal libraries. You're not allowed to choose which version of a library you want. Everyone at Google uses the same version. And you can imagine that causes great complaint because there's good reasons to have this version instead for my project. That's not up for discussion, right? There's a single version in general of things that are libraries, and we use that. That's the trusted one. That actually makes a bunch of things easier, but it's very unrealistic for the broader open source. So we can't get that to work directly. I don't want to cover this detail either, other than say we released a thing called Salsa, which is really a framework for supply chain security. You can think about it this way. These are the invariants you need to hold if you want to have a trustworthy supply chain, right? So it's really about the invariants. That little table, which I know you can't read, is actually different kinds of invariants, things like code review. There's little columns, Salsa 1, 2, 3, and 4, which have to do with kind of degree of security, because it's hard to do all these invariants. So the ordering means you can get some basic things like, do you know your source code? Right? Are you really using the source code you think you're using when you build something? That's the kind of an easy invariant to get to. Down to the end, is it hermetic, meaning things like there's no network connections required when you build it, so you know that these inputs produce this output, and everything is signed with what compiler was used, what inputs, what steps, what reviews, lots and lots of metadata. So there's a framework to fix this, but again, to adopt this for every ecosystem, for every build system, is going to take a long time. But that is the direction we collectively have to go. I'm going to wrap up. So I'm a big believer in open source. I want it to rule the world. And I think it has already greatly increased the rate of innovation in many sectors. But it needs maintenance. Right? You think about, we spend U.S. is spending $1 trillion on infrastructure. We don't spend anything on our software infrastructure, right, by comparison, right? So, we need these kinds of, we need the maintenance that you need for any infrastructure. It needs to be paid for in a sustainable manner. So we're trying lots of experiments, direct funding of foundations and maintainers. I started something called OpenSSF, Open Source Security Foundation. That's part of the Linux Foundation. That's kind of the industry place to actually have these discussions. It's also, we just did the White House summits. The last one was in May, just directly discussing these things. We'll be going to UK and Germany also to have meetings with those governments about how to move open source security forward. And personally, I'm really working on 3 things, and I'll get to what you can do. But OpenSSF as a neutral place to sort out these hard problems, like how do you sign things, how do you get what's the right metadata for things, how do we incentivize maintainers to do the mundane work, how do we get them money. I do believe open source is a public infrastructure and a public good, and like all such public infrastructure and public goods, should be publicly funded. That is a tall order, but it's a reasonable request, and we'll see if I can make any progress on that. And finally, one I talked about today, we need more curation. Right? We need to take seriously the role of accountability, separate from distribution, and find ways to use that to really take advantage of the top-down pressure and interest to actually cause the right things to be looked at and the right things to be fixed. Right? But you can't just tell maintainers what to do. You can't send them legal requests. You have to make them part of the system in a way that's inclusive and that they want to participate. And I think there's a path to doing that. What can you do? Well, if you're a government, besides funding, I do think most groups, governments and enterprises, haven't thought about what are they using that's as is versus when do they actually want accountability. And they should and do pay for accountability today, but they should be more conscious about it. I think you should support the things you use. Most companies support their own open source projects, but do you support the projects that you use, like your dependencies or things you just happen to use? So nice stat here for Google, 75% of the GitHub repos to which we contribute are not projects that we started. So if you take out Kubernetes and things that we started, right, that's 25% of the things we contribute to. 75% of the contributions go to things that someone else worked on, and I think that's the right model, right? So if you're a company and enterprise, I think about, can you do your share to support the things that you didn't create, right? The things you're users of, not just creators of. For maintainers, I won't go through this one for this audience, but I hope maintainers will work with curators, think about curators for their own dependencies, enable build and test by others who pay for it themselves. Again, Google, I'd be happy to volunteer Google to do more testing of open source packages if you tell us how to run the tests, basically, in some systematic way. And finally, if you're in academia or a funder, I'll just put a list of problems here that I think need systems-like help, right? This community has been fantastic at producing open source, but not really great at helping open source do the mundane, right? What's the tooling that would make a big difference? What's the automation that would make a big difference? And there's a whole bunch here, but for example, cherry picking, that's the process. If I have a security patch for the new version, can I make it work on an old version? And that's a hugely important problem because most users are stuck on an old version. And it's actually going to be much easier to cherry pick that patch than it is to get them to upgrade to the new version. Right now, we expect them to upgrade. It's not a reasonable expectation. All right, I will stop here. I should say, NSF does have one small program in open source, which is about how to turn open source projects into healthy ecosystems, like a Spark and Databricks, or like a Kubernetes. But they're open, because I've talked to them about broader programs that would benefit open source, and I hope to cause that as well. So I'll stop here, take some questions, and thank you for your time.